Well, good morning there from Santa Cruz, California. Today we're going to be working on functions, and there are a lot of different kinds of function problems that look all different kinds of ways. Some are super easy and some are a little bit more complicated. So I would like to start out with just some basics on functions. So a function looks like this, and you say it f of x. And often they'll give you just a simple problem. F of x equals 3x plus 1. And they will say, what is f of 4? And as you might be able to see, the x is in the same position as the 4. And here's the tip. Anything in the parentheses is always equal to x. So what we're doing is simply substituting the x with the 4. Okay, so we get 3 times 4 is 12 plus 1 is 13. Okay, that would be the simplest kind of problem. Let's see. Another kind of problem they may give is they may say f of x is 4x plus b. And then they might say f of 5 is 8. And then they might ask for, what is the value of f of negative 2? Okay, so what we would say is, same thing, anything in the position of x is equal to x. So in this case, we have 5 is in the position of x. We start with what they first give us, and we put that in. So we can say, I think I'll just put it up here. We've got 4 times 5 is 20 plus the b. Now, they also tell us, and now that it's equal to 8. So now I'm going to just bring it down here. We have f of 5 equals 8, and we just put it into our initial function, and we know it's also equal to 20 plus b. Okay, so now I think I'm just going to write it out here so I can actually do some work. We've got 20 plus b, and now we can actually solve for b. We just subtract out the 20, we get negative 12 equals b. So now when they say f to solve for f of negative 2, I think I'll rewrite the initial problem. So f of x equals 4x plus b. Now we have f of negative 2. So we're going to put negative 2 in the place of x, and we just solved for b, right? We know that is negative 12. So now we can solve the entire problem. We've got 4 times negative 2 is negative 8. We've got b is negative 12. So this together is going to be negative 20. That's our answer. Okay, so when they tell you that a function equals something, I'll put this in a different color. Here, they tell us that the function equals 8. When you do your substitution, you then make that, what you come up with, equal to the 8. And that's the way to solve for it. Okay, so here is another way that it could look. All right, so let's say it's f of x. And by the way, it doesn't have to be an f. It could be any letter at all. So it could be g of x or j of x or z of x. Okay, so let's say f of x equals 2x plus 5. They might say, what is f of negative 4x? Huh. Now that's weird because so far we've only had plain numbers in the parentheses. Doesn't matter. Don't get fooled. You just replace the x with negative 4x. So you just put negative 4x in to replace the x just like you would any other number. If it was 4 or negative 4, you'd do the same thing. And then you get 2 times negative 4x is negative 8x plus 5. And that's it. That's as much as you can do. So a question like that is going to look a little bit different than, just a regular number. Okay, so that's that. What else could it look like? I think I'm going to clear the decks here. All right. Now, let's say we've got, you know what? Let's go to our actual test. We can do test 1, section 3, number 10. All right. Now, we see we've got, oh, here we have a g of x. Okay. It's the same thing. It doesn't matter. And, all right. So this is the given. It says for the function g defined above, a is a constant. And by the way, a constant, when they say something is a constant, it either means that you can just plug in any number for it, or you don't even have to do that. Just to know that it's not a variable, that number is going to stay the same, or that letter. Okay, then they say g of 4 equals 8. So without even going further than that, we know right away that we're going to put 4 in for the x. So we put the 4 in for the x, and we know that whole thing is going to equal 8. So we can do that. We can just do it up here. So we know that 4 squared is 16. So our first element is 16a plus 24, and we're going to make it equal to 8. And then we can solve for a. So we subtract out that 24, and we get 16a equals negative 16 divided by 16, and we get a is equal to negative 1. Now we read on, and it says, what is the value of g of negative 4? Now, we can go through the same thing. In fact, let's just do that. I'll use a different color, and maybe I'll rewrite it. I think that'll be easier. So we have our initial function, g of x, is ax squared plus 24. And we're trying to now plug in, and I'll use a green here, negative 4. So put a negative 4 in, and we'll just continue. Negative 4 squared is 16a, but we just solve for the a, right? So we know that a is negative 1. So we can put in negative 1 here plus the 24. So we have negative 16 plus 24, and we get 8. 8 is our answer. Now, I want to show you a little shortcut because you didn't need to do it this way. All right. If you had seen that the number that we're changing is x, and that number is squared. So if you caught that, x squared is going to be the same. It's going to be, in this case, 16, whether x is plus 4 or minus 4. Now, if you'd caught that, you'd say, oh, it's not going to make a difference. The answer is going to be 8 both times. Okay, there's a shortcut. It's not a big deal if you didn't see that, though, because it wasn't too hard to actually just work through that second half of the problem. Okay, let's see what else is interesting on this test. I think I'm going to clear it out. And if we continue with test 1, section 4 this time, and we're going to go to number 17. This is another way that functions can look, right? It's on a graph. And I'm going to try to do it decently, but it doesn't have to be perfect, luckily. So it goes up, and then it goes that way, slightly up, and then slightly down. All right. So, and it says y equals f of x. You know, this is a good segue, actually. Here's what I want to point out. This is a really important point that will get you far. Okay? The thing in the parentheses, as I said before, is always equal to x. However, the entire function, in other words, f of x, is always equal to y. And here they just say it. Okay, but we'll probably go over questions where this becomes important. But I want to just plant the seed now. Okay, now let's read the question. It says the complete graph of the function f is shown in the xy plane above. Blah, blah, blah. We always know whenever there's a picture, the first sentence always describes that picture. Here's the important part. For what value of x is the value of f of x at its minimum? Well, remember when I said we'll probably do a problem where this here becomes important? Well, here it is. It says, for what value of x is the value of f of x at its minimum? So for f of x to be at its minimum, that's the same thing as saying y is at its minimum. Okay, so now the question is, for what value of x is y at its minimum? And y, of course, is this axis here. So we're looking up and down. Clearly, this is the minimum. I'll do it in a different color. Right? There's your minimum. Now they're saying what value of x is that? So you're just going to go up from here to the x-axis and whatever that lands on in your picture, right? So you can see if you just go up to the x-axis and then count in to the origin, it's going to be -3. -3 or b. All right, this is important. Here is your takeaway right here. The thing in the parentheses is equal to x. The entire function is equal to y. All right, now let's see what else. Let's go. We have room on this screen, so let's go to test 2. And we'll do test 2, section 4. We've got a few questions here that are good. Let's do number 10. This is an interesting question because you see there's a lot of functions in this one. So the first thing we have is f of 2 equals 3. And then f of 3 equals 5. Okay, that's great. Then it says a function g satisfies g, oh my goodness, g of 3 equals 2 and g of 5 equals 6. What is the value of f of g of 3? That's how you say that. Now, when you've got a function within a function, you start with the innermost function. All right, so that innermost function is asking, what is g of 3? Well, they just tell us, right? That's right here. G of 3 is 2, so we just replace this g of 3 with 2. Now what we have is f of 2. And hey, they tell us f of 2 is 3. That's it. F of 2 is 3, and that's our answer. Again, B is our answer. Okay, so the main takeaway here is that you must start with your innermost function when you have a function within a function scenario. Okay, now let's go. I'm going to clear this out again. Let's stay with test 2, section 4, but let's go now to 26. And we have another graph. But this time the question is quite different. You can see we have Roman numerals there. So we've got something like, we go up here and then down, across and down. Okay, so it says the complete graph of the function f is shown in the xy plane above. Which of the following are equal to 1? All right, so let's figure out what this means first. Okay, but we have to focus on our Roman numerals. So we've got, let's take the first one, f of -4. Well, remember always the thing in the parentheses is equal to x. So when we go to f of -4, let's say that is -4, and the question is saying which of the following are equal to 1. That's saying, is this equal to 1? All right, so what another way of saying that is y equal to 1? Is the function equal to 1? Okay, remember we said the whole function is equal to y. Okay, so what we do is we go to our x value, which is -4, and we go up to that line, and the question is that point at 1? And we find that it is indeed. So what I want you to do is circle Roman numeral 1 and immediately go down to your answers. Any answer that does not include Roman numeral 1 goes away. So that's awesome. That means we have A and C. Get rid of immediately. And now we go to Roman numeral 2, which says f of 3/2. So we're going to do the same thing. When we go to 3/2 or 1.5, right, is that equal to, it's going to be 1.5. If we go up to the line, is this equal to 1? Now, my picture is off, okay? But if you look at the picture in front of you in print, you'll see that yes, that is indeed at 1. Okay, so any answer that does not contain Roman numeral 2 goes out. And we can see B does not contain Roman numeral 2. We are done. Our answer is D. Okay, just as simple as that. We don't even have to worry about Roman numeral 3. We do not need to do it. So remember, with your Roman numerals, always go back and forth. Solve for one Roman numeral. If you like it, circle it and cross out any answers that do not fit. And most of the times, you don't need to work through all 3 Roman numerals. So it's a strong strategy. Okay, clear once more. And we're going to, again, stick with the same test. We've got one more question. Test 2, section 4, number 33. And it says, in the xy plane, the point 3, 6 lies on the graph of the function, and we're going to write that down, f of x equals 3x squared minus bx plus 12. I love this question because in truth, it's not actually a function question, but because there's a function there, I put it under the function category. But here is the super shortcut, which I love. Anytime there is an x and a y, all right, here are your x's, and here is your y, and there's a coordinate with an x and a y, you just simply plug it in. So you're going to plug in the 6 for the y and the 3 for the x. So this is going to be 3 times 3 squared minus, we'll put the 3 first so it looks normal, and then we're just going to solve. We have 6, and of course the question is asking us for b. Obviously, it's the only variable left. 3 times 3 squared is 9, minus 3b plus 12, right? And this is how I want you to do it, not skipping steps and not doing math in your head, which makes for bad math. All right, we've got a 12 and a 27, which is a 39 minus 3b. We're going to get rid of this 39. 6 minus 39 is negative 33, and we've got it equaling negative 3b. Always remember your negatives. It's so easy to just, I don't know, somehow skip over them or just leave them out. The answer is 11. All right, I love this strategy. Please remember it. All right, and that's it for that test. Now, what else? I'm going to clear this out again. There are a few other types of function questions that I've seen, and one involves, again, a graph. So let's say that we have a function, and it's something like 2 to the x plus 1. And they want to know what, and they don't tell you, they don't give you any graph. Okay, that's all they tell you. And then they want to know what a graph of negative f of x will look like. All right, so this is the big question. All right, now this is definitely a more advanced question, function question, but if you know how to do it, the math is not bad. So let's go here. Okay, we're going to focus on the function that they give us. And remember, this is the same thing as saying y equals 2 to the x plus 1. And we can just simply plug in numbers, right? So we'll do this off to the side. If we come up with, I always do 0 and 1 for my x. So what I'm saying is, if you plug in 0, what is y going to be? Well, you're going to get y equals 2 to the 0 plus 1. 2 to the 0 is always 1. So you're going to get y equals 2. Okay. Now, I think I'll rewrite it so it's nice and clean. Y equals 2 to the x plus 1. And now if we plug in a 1, we're going to get y equals 2 to the 1 is just 2 plus 1. So we're going to get 3. Right? Now this is what we have so far. Okay, so let's just graph it. We've got 0, let's say this is 2. So that's our first point. And we have 1, 3. Let's say 1 would be here. And 3 is going to be 1 up, like that. Right, so we're going to have a kind of curve that'll be like that. All right, positive curve. Now they're asking us to make it negative. But if you notice, the x's stay the same. Okay, so let me label this here. This is going to be our f of x. And now we're going to do the same thing with negative f of x. Okay, so x and y. Remember I said the x's stay the same. So we're just going to plug in 0 and 1. But now the y's are different, right? So here, I'm going to use a different color. Here, our y is positive. Here, our y is negative. So our y's simply look like the same thing, only negative. Okay, so we have 0, negative 2 now. And now we have 1, negative 3. It's going to go down. So our curve is going down like that. And what is the curve? I mean, you would have, now let's see, you would have various looking curves. You know, you'd have like that and that. And what other? You might have like this would be the right one, like that. Not say C is the answer. And then you might have something like that. Right? But if you just graph it out, you'll be fine. The main thing here again is to understand what they're talking about with the x's and the y's. And just notice that this is a pretty nuanced question. I will say this is definitely a more difficult question. Okay, and you get to decide if you do it or not. And I'm going to clear this out. Okay, our next problem. Let's see. Yeah, we could have something like, and you've seen this before, depending on the order that you're watching your videos in, where you have a table, right? You'll have like x and f of x. And then you'll have a bunch of numbers, right? And then for the answers, you'll have various functions, right? So this could be f of x equals 2x plus 1, and f of x equals 3x minus 5, and so forth. And let's say this is 0 and 1, and 2 and 4, and 3 and 7. And your job would be, like, the question would be something like, what defines the relationship? And you would simply plug in. So let's say you would take x for 0 and y would be 1. And you would just see, does this work? Well, it happens to work, so you'd leave it in. And you'd go straight down. You'd go 0 and 1. Oh, B doesn't work, right? And let's say C doesn't work, and D does. And D probably would work. This is very common scenario. Then you would have to go to the next line. Then you go, I'll do it in a different color. You'd say, well, we did that. Now we have to work on the 2 and 4. So we'd plug in 2 for X and 4 for Y. And we'd see if that worked, right? We'd say, 2 times 2 plus 1 is not 4. It's not that, it must be D. Okay, so defining the relationship by plugging in numbers from a box. Okay, so let's see, is there anything else to discuss here? I think that's it. Let's see, you know what? I think there's one more. Yeah, one more that I want to do for sure. Okay, so let's say this is also a more difficult one, and it's going to be similar in the sense that there's a box with X and f of X, but I'm going to get more specific here. Okay, so there's X here, there's f of X here, and now we're looking for patterns here. We've got 0 and -2. We've got 2 and 4, and we've got, whoops, that's a 6 and 16. All right, now the question is, what is the value of f of 3? All right, now remember, f of 3 means that x is 3. So let's just put a 3 right in there. 3 is going to be in here somewhere between the 2 and the 6. But what we need to do is look for patterns. So the best way to do it is just look what happens as we proceed. So when x goes up by 2, right, from 0 to 2, so I'm just going to write this out. When x increases by 2, what happens to the y? The y increases by that 6. So you have to remember, it's not going up by 2. This is a negative here. All right. Then we can say when x goes up by 4 from 2 to 6, right? When x goes up by 4, y goes up by 12. Okay. Well, let's just see. Now, I think I'll do this in a different color. Now, if we had x going up by 1, because we're trying to find f of 3, if x goes up by 1, what would y go up by? Okay, now we can actually get into a little bit of proportion, right? We can have x's on the top and y's on the bottom, right? So if we have, when x goes up by 2, y goes up by 6. If x goes up by 1, y goes up by what? And we cross multiply, and we get 2x equals 6, x equals 3. So that means y, well, I mean, it's a little, I shouldn't have used x. Let me just say, let's say this is a, because now it gets confusing. You think I'm solving for x. Okay, sorry about that. All right, a is 3. And by a, we're meaning what does y go up? We're solving for how much y goes up. Well, if y is going up by 3, we're going from 4 to 7. Okay, do you get it? It's all about a pattern. It started with what they give us. Now, we didn't really need to figure out, I guess I complicated it by giving you this. We didn't really need that, right? We didn't really need this because we didn't use it, okay? We just figure out the pattern. What happens when x goes up by certain? How does y go up? Okay. Anyway, I know this is like a more complicated problem. It's okay. If you get it, wonderful. If you don't get it, it's not really a big deal. You probably never see a problem like this. And if you do, there would be one of them on the test. So please don't worry about it. Anyway, that's functions. Mostly it has to do with substitution. Okay, my dear, I will see you next time. You take care. Bye-bye.